Great, thank you. Warm welcome to everybody again. Good afternoon, good morning, good evening, depending on where you might be joining us from. My name's just briefly Martin Strempel, obviously also from iTech, like many of my colleagues today. Currently in the role of business development, specifically for the data analytics and data analytics suite that we have. And within that, we will see also specifically things like the iTech Asset Analyzer. I've been working in software, at least or software on the shop floor for over 15 years now. A large part of that was spent actually in production management and production control. And that's really sort of where the idea of my presentation today originates. Something a lot of us take for granted in manufacturing. Something that we've built many of systems we've seen today, this discussed numerous times around this topic. Something we showcase in reports, quoting meetings, and endlessly try to optimize. And that something is our OEE, our overall equipment effectiveness. And while this is a trusted metric and has been used for decades, it actually has some significant flaws. The secret that is costing manufacturers time and money and clarity. So today, a little bit more away from the technology. This is a little bit more philosophical in terms of a journey I'd like to go on with the audience today. But I would like us to rethink how we measure what truly matters in the production line and production facility. So the big question, let's start with the basics, right? OEE is simple. It is the availability, the performance, and the quality. And if we multiply these three factors together, you get a number that supposedly tells you how well your complete operation is performing. That sounds great, and it's easy to understand. Managers love it, operators know it, consultants, they swear by it. But there's a catch. The simplicity hides all of the complexity. So it's kind of its own undoing in that sense. In today's factories, where nothing is simple anymore, that is actually becoming quite dangerous. So on today, I will kind of take you through this journey just to ask a couple of questions. So why OEE was once useful, maybe what's changed, the hidden costs of keeping it alive, are we fitting a square peg here into a round hole? And is that really still what the original purpose was of OEE? And then what happens when we chase this metric? And what if this metric is wrong? How can we shift from reporting performance to actually understanding what's going on in our operations? This is not about an incremental technological improvement. This is about a paradigm shift from machine metrics to actually understanding our systems, to cognition of what's going on. So I'm sure we are almost all aware, especially if we've been working in manufacturing for a little bit, that OEE was born in the 1960s in Japan as part of the total productive maintenance. The introduction of this time was all around lean production. And this was a time when factories were stable. They were running few products, and the lines were pretty much linear compared to today. One product, one cycle time, one machine at a time. In that world, OEE makes a lot of sense, right? And for years, this worked, especially in industries with high volume and low mix environments like automotive and consumer electronics. But here's the reality, as we all know, and we've actually seen many allusions to this today in many of the presentations that have come before me, right? We no longer live in that world. So modern factories are very, very different, right? We have seen today how high product variability affects all of our production, how it creates a huge number of additional decisions that we need to make. We've just seen how that affects traceability in the previous, traceability and compliance in the previous presentation. We have much, much shorter life cycles when it comes to products, right? Which means if there changes, these could always be substantial, and we need to think about how that might affect the OEE calculations. We have dynamic routing, we have changeovers, we have, even in the most modern factories today, software-defined workflows that change dynamically depending on situations and conditions in the factory, right? We have machines and humans now working side by side in the modern factory. And yeah, so, and if we really think about it, this is kind of why it's becoming so challenging for us to review OEE in a modern factory. And we're finding more and more that this is becoming more and more difficult to do. And that it's becoming very challenging for the OEE actually to represent something that is meaningful for us to actually make decisions on. So I want to make this a little bit personal. I'll share a true story from my side. At this point, this was for a larger manufacturer where every minute cost a fortune that we were standing still. And there were basically 3 shops. And our OEE at this point, this is quite a while back, but it was reflecting always green across the board. So we always had 90%. Perfect charts. And at that point, it kind of puts everybody into this mood. Okay, everything's running well, we're doing well, and things are going great. But that was not really what was brewing underneath, right? We were actually kind of blind to what was going on, because there's a lot of things that OEE wasn't telling us, and it wasn't showing at this point how fragile our system had become. So then things started to go wrong, right? We started to have small breakdowns, especially early on in the production area, right? Mainly in the first shop. And the effect was that during the week, our buffers would start to drop. And just like that, suddenly we started missing target after target. We struggled to get to our volume at the end of the month, and our costs of keeping everything running was skyrocketing. So this is kind of what I really want to get down to. Although everything was green on the OEE side, we were actually in serious trouble. And the premise here for this discussion is, why was OEE not showing us more, actually showing us that we had a problem? So this is where the real pain lies, right? Not only does OEE have this blind spot, but to keep it running, we also have to heavily spend on system integration. We've just seen it also discussed a number of times today, right? We have huge costs. We have huge integration projects. We generally need custom rules if we want OEE to be transparent enough kind of to avoid the kind of previous scenario that I've just sent, which means we need to specialize it. We need to customize it almost for every scenario. Human intervention is often required just for the numbers to make sense, which makes it by default unreliable, especially across facilities or different plants and countries or continents. And this manual input actually also requires a lot of additional work, right? So we end up paying people to tune these formulas, people to adjust our integrations, we adjust our formulas, and so that we don't lose the transparency that we need for the metric to actually work, but all within this context of the factory becoming more flexible and more adaptable. This is becoming a greater and greater threat for factories as we go along, right? And this ought us to calculate a number that doesn't actually reflect how the system is truly behaving. So, what is the alternative, though, you might be asking? This is not just swapping one KPI for another. It's actually a cognitive shift that is happening in industry at the moment, right? And this is where I'm actually also really excited about what's going on, right? We've moving from measuring the machines to actually modeling the systems when it comes to performance management. We're going from snapshots of what's happening to actually an understanding of the continuous system and how the system interacts amongst each other. And we're going from rules to a system that can learn and adapt to these conditions. And this is where cognition kind of enters the picture, right? We're not really talking about artificial intelligence for the sake of a buzzword or for being, but for it actually being adaptive and being able to explain with some sort of causality what is actually going on in our factory. So there's also what tools like the ITAC asset analyzer have been built for. Instead of us needing this full integration, this full picture from day one. I mean, you can imagine typically to measure OEE, there's a huge technological debt and integration cost that is needed right off the beginning, right? You have to integrate the machines, you have to interpret the machine states, you have to map these to, we saw even today, to the logics that you want to use to calculate your OEE. You probably have to verify it. And then once you've started that, this is kind of this iterative loop that you keep having to readapt the numbers to reflect what's really going on. The political part always enters the conversation, right? There's always somebody who feels that in an organization that OEE has been calculated incorrectly. And it just generally doesn't lead to a very clean, actually, calculation, even though it's supposed to be so simple for us to do, right? So instead of needing full integration from day one with this kind of new technology emerging based on our real-time streaming analytics, we can start with a minimal data connectivity. In the presentation today from Sebastian, we saw that by just monitoring how many units we've produced at each machine in our production line, we can already determine a huge idea and create a very good picture of what's going on in our production line, right? And that's where we start. Minimal machine data. You don't really need custom connectors from that point, right? And then you can start adding all of the additional details you need as you're going along for this kind of understanding and contextualization of what's happening in production. This is a huge area where obviously large language models are adding a huge amount of flexibility to us, right? We can basically feed these systems now unstructured data. Think of log files, think of reports. Not only like, you can also add voice notes, videos these days, everything to the system, and let the system interpret them, understand them, categorize this, and then add it into its idea of what's actually going on in your production line. And it builds this much bigger general understanding as it goes along of what's happening in your production line. So it learns how your line behaves, it learns how flow moves, it learns how the assets interact, and it can actually start then to explain the anomalies and not just flag them. Oh, sorry. And the nice thing is that it actually reduces, it's not more expensive than doing it the traditional way. Quite the opposite. It actually reduces your debt and your integration work by allowing you to start with what you already have and grow that over time. So let's not forget the human side, looking forward as well. More and more factories have this knowledge that doesn't live in dashboards alone, right? It lives in the people. We've also referred to it today in a couple of presentations, right? We have operators, line leaders, maintenance crews that all make very small decisions, but these all critical for actually a high running factory. In fact, it is actually said that the IP of a manufacturing house is not in the equipment and the products it produces, but in its people's understanding of how the processes run and keeping those maintained and keeping those the machines delivering the products as you require. So in that sense, why are we not focusing on that? Traditional systems ignore that, or at least I don't know if they ignore it so much as in the past it was too difficult for us to actually attempt to capture this data from these people, from these operators, from these leaders. And that's again where LLMs and large language models have become a huge, huge step forward right now. Modern ones, you can actually just upload voices, your voice recordings, your videos, your behaviors. It can introduce from your interaction cues with the dashboards that you're working with what you were doing, and not just what the machines are reporting, right? And this is how we capture what is now being coined in industry as tribal knowledge, right? And turn it into an institutional learning. So let's recap. Think of the human bodies. Senses are great, right? But what makes them intelligent? isn't just sensors, right? We have a nervous system that interprets what's going on, and we respond in real time. If you think of dashboards as sensors, kind of, I guess your OEE would be a thermometer. Modern systems like the asset analyzer are more like central nervous systems, right? Continuously inferring from the understanding and adapting. They don't need a full set of data up front, but they can work with uncertainty. They can work with partial views and still try give meaningful insights. This is kind of what factories need at the moment, right? It's not a pretty report, but something that can link all of the causal effects it's seeing into an understandable and interpretable result, a type of brain. So I will go back to our original example. In that case, I said, and I mentioned we've had OEE over 90% in all three shops, right? But what didn't help us is when the flow broke down, we didn't see what the buffers were, right? The buffers weren't being monitored. It was too expensive to monitor the buffers, and immediately that created a gap in our knowledge. So what was happening is that we were running production outside of the planned schedule. Another thing the OEE didn't pick up, because OEE was only being calculated according to the planned production times. Anything outside the OEE, any units produced were just ignored. So what was happening, in order to make sure that production ran smoothly, all of the buffers were being filled up on the weekend. And slowly, if something happened during the first 2 or 3 days of the week, all of those buffers would be depleted in 1 or 2 hours. And this would leave the system lean. And then the actual truth was that when we were running lean, we couldn't actually meet our takt time or cycle times. And we struggled for the rest of the week, which is why we would always have difficulty making our production targets at the end of the week. Our systems back then did not pick up on all of these problems. The question is, would modern tools do that? And I'm quite sure they do, right? They can handle and work with asymmetry and nonlinearity. Modern tools that have the available data would pick up that there was production happening outside of the planned production schedule. They would be able to detect bottlenecks. We discussed that if we have this approach where we don't need too much data to start, right, we can actually monitor a lot more of our assets than just the main ones or the main outputs of our shops, but can actually track individual machines. That would allow us to create a complete picture of the flow in the whole factory and not just see the individual outputs. So we would pick up on things like the skeleton crews working outside of the plan, and crucially, infer the causality, not just the correlation between all of these individual items. So to close, we've been chasing performance through a static metric, right? We're paying a steep price to get, in terms of complexity and integration, to get this system up and running, and there's huge integration debt. The question I wanted to present here today is it maybe not time that we stop investing in an old metric that is almost 60 years old and start investing in understanding. We've seen that instead of measuring OEE, if we measure things like downtime, and if we can attach reasons to downtime, this is a much bigger tool for us to be able to actually analyze our environments and actually improve our production and performance over just monitoring OEE, right? Which sometimes just gives us the illusion of control, while we could actually be bleeding huge amounts of money. Chasing OEE comes with massive costs, and it's a question if this should be done as pedantically in the future as we might be doing it today, right? We are unknowingly spending millions to keep OEE relevant, keep adopting it to our latest production. We keep having to customize integrations, manual inputs, data normalizations, logic layers, all just to produce a metric that actually doesn't even drive maybe potentially decisions, or even drives us to make the wrong decisions. Factories are really spending real money to maintain a false sense of performance. And then factories are living systems. They need cognition, not calculation. the situation with high mixture and high volume and low volume is actually, and more variance is just going to keep increasing, right? We have systems that need to be able to infer, adapt, and explain, and not just statically calculate and measure these kind of performance things. We need to replace these kind of static dashboard concept with something that is responsive, aware, like downtime trackers, right? This approach is much leaner, much more flexible, and much more adaptable. And the technology is getting better and better. My postulate is that what we need in future is smart metrics for a smart factory. We should not be building our smart factories with a 60-year-old metric that doesn't even fit the picture of a modern factory anymore. So thank you for your attention. I hope I at least managed to create some thought and send you guys home with a new idea. And if we have the time, Alina, I would love to take any questions.
Yes, thank you, Martin. I think it gives everyone the opportunity to think on what to do in the future. So thank you for that. Thank you for the insights. We do have some question. I would start with the first one, which is, I think, a pretty valid question. So isn't OEE still useful, at least as a baseline indicator, even for modern factories? What do you think?
Absolutely. So I think OEE will remain that way, right? It's easy to start with. And we've also seen that a lot of the cases with MES, we need all of this functionality in the first place. We need the compliance, like Andreas just showed us. That's not something that will disappear any day. We need to be able to monitor and track and trace everything. So a lot of the time we have the building blocks that we need to get the OEE up and running. The question is as soon as you start needing massive integrations and custom logic per machine with endless kind of tweaks that just to get this static number out again, that doesn't always reflect what's really going on. At that point, I say, does it really make sense to keep a simple KPI like that running if it's costing you millions of euros as an IT project to do it in the first case?
Okay, that's good to know. A second question would be, in what ways can a future factory systems integrate human insights and tribal knowledge to enhance operational understanding and resilience?
Well, I think that is very much where the new tools that we kind of shown allow us to get much more visibility about how we're interacting with the machines as humans. I think we reflected briefly on also that the future does not lie in AI telling us how to steer factories, but rather with us working together with AI to be more efficient at running production. And this is sort of kind of which forces us to build the whole kind of integration puzzle up front, right? And LLMs and using large language models and are allowing us to create structured data and out of this what would otherwise be classified as unstructured data, and have allowed this whole idea of adding the human content into the system, scalable and flexible in the future.
Mm-hmm. Thank you. A further question is, what are the advantages of using AI-supported tools like the ITech Asset Analyzer that you mentioned over static KPI-based performance tracking systems?
Well, I think it's kind of the crux of the whole presentation. So at the end of the day, we using the AI tool will allow you to adapt flexibly to what is going on in your production line, and will give you full visibility potentially over things that are really happening and highlight what the information that you should be knowing. Whereas OEE might be a nice metric and static KPIs might be a nice metric to create a comparative result just to see when one is lying. But actually, because they are so simple, reflect a lot of the detail that you need to meaningfully do those comparisons. And AI and the ability to interpret all of the context into what's going on to the production was giving us an ability to do an objective comparison that goes beyond just measuring KPIs, right? It includes the reasons why the KPIs are different and what might actually be underneath the KPIs that are the root causes of that. So I think of KPIs as kind of more sort of the projection, kind of the shadow of the fire, of the people dancing in front of the fire on the rock cave wall, as opposed to actually looking at what the people are doing, and I think it'll be a big significant change for factories in the future, and using this technology to optimize production and software.
Mm-hmm. There's also one more interesting question over here. How can we address the OEE topic with old-fashioned, so to say, clients? So how can we tell them that this KPI is not the one they should be looking at?
Well, I think it's not that we need to throw out the OEE idea at all, right? We just need to reflect at what makes sense to us, for us to still use OEE as, and for what, and from what point should we move away from OEE. If we are spending, like I said, if we're spending huge amounts of effort and money involved in getting the OEE and getting it to a point that everybody's happy, and we're catching and captivating all of the nuances that are required for us to use it as an objective KPI, if that is easy to do, then it makes sense to keep the OEE as a KPI. But as soon as we start moving into situations where those nuances and contextual inputs into the calculation change all the time, then we're moving into an area where flexible things like downtime tracking, where we're attaching causality to the reasons for the downtime through modern LLM infrastructure, is much more of benefit than spending that money on getting that square peg into that round hole.
Mm-hmm. I think we got time for one last question. You talk about systems that understand flow and context, but aren't those very hard to implement in real factories with legacy equipment?
I think that's again the beauty of doing it in a kind of adaptive way. One can, with this technology, you can start with the basics and keep building. The systems and the way they function are very different to maybe the way that your traditional MES works, right? Your traditional MES needs a whole preset list of requirements for it to actually be able to give you things like the OEE, to give you full tracker traceability. And that is why MES projects have such a long integration period up front. Tools like this, where we're looking at it being flexible and adaptive to the situation, can start with the most basic information and already feed you what the systems can interpret from that information back. And as you start adding more and more layers into the system, it's not a reintegration of the efforts, rather you adding more information into a system that can adapt to the information you're feeding it. So it keeps getting more detailed and keeps being able to give you a more refined answer to the questions you're asking.